Have you ever wondered what the fabric of reality is made of? What if we told you that at the tiniest scales, the universe behaves in ways that defy common sense? Welcome to the world of quantum physics, where the bizarre is the norm and the impossible becomes possible. Let's start with wave-particle duality. Picture a world where particles like electrons and photons are both actors and spectators, playing dual roles. They exhibit both wave-like and particle-like properties, almost as if they can't decide what they want to be. It's a realm where the lines blur, and particles can be in two states at once. Next, we have quantization. Think of it as a staircase. In our classical world, you can stand anywhere on the staircase, but in the quantum world, you can only stand on certain steps. Quantum systems have quantized energy levels. The energy comes in discrete, distinct values, leaving no room for the in-between. Now imagine a particle with a split personality. This is the concept of superposition. Particles can exist in multiple states simultaneously until observed. It's like they're waiting for the spotlight before they decide which role to play. Finally, we come to Heisenberg's uncertainty principle. It tells us that certain pairs of properties, like position and momentum, cannot be precisely measured simultaneously. Trying to pin down a particle's location without disturbing its speed is like trying to catch a slippery eel. The more you try, the harder it becomes. These principles form the bedrock of quantum physics, a world where particles can be in two places at once, and certainty gives way to probability. It's a world that challenges our classical understanding, defies logic, and invites us to let go of what we think we know about reality. So buckle up, because we're just getting started on this quantum roller coaster. The quantum world might seem abstract, but it has been confirmed time and again by mind-bending experiments. Let's begin with the double-slit experiment. Picture a particle being fired at a barrier with two slits. Instead of passing through one slit or the other like a regular particle would, it creates an interference pattern on the other side. This suggests that particles behave like waves, spreading out and interfering with themselves until observed. It's as though our act of observing compels them to make a choice, a phenomenon that vividly demonstrates the wave-particle duality and superposition we discussed earlier. Next on our list is Schrödinger's cat, a thought experiment that seems like it's straight out of a surreal dream. Imagine a cat inside a sealed box with a mechanism that could randomly kill or spare it. Quantum mechanics suggests that until we open the box, the cat is both alive and dead at the same time. It's only when we observe the cat that it snaps out of this superposition and becomes either dead or alive. This experiment, though purely theoretical, provides a stark illustration of the concept of superposition. Now let's move on to quantum entanglement, a phenomenon so bizarre that Einstein once referred to it as spooky action at a distance. When two particles become entangled, their properties become instantly connected, no matter how far apart they are. If you measure one, you instantly know the state of the other. It's as though they're two parts of a whole, communicating faster than the speed of light. This experiment showcases the inherent non-locality in quantum mechanics, a concept that seems to defy our everyday understanding of space and time. Finally, we have quantum teleportation, a concept that might sound like it's from a science fiction movie, but is very much a part of our quantum reality. This isn't about teleporting matter, but rather about transferring the quantum state of one particle to another. It's like faxing the information of one particle to another, making it an exact copy of the original. This is a critical concept for the future of quantum computing and secure communication. These experiments reveal a reality far stranger and more wonderful than we could have imagined. They challenge our classical understanding of the world and open up a realm of possibilities that stretch the limits of our imagination. Each of these experiments provides a window into the enigmatic world of quantum mechanics, bringing its abstract principles to life in the most unexpected ways. They remind us that at the heart of our reality lies a quantum world that is wonderfully complex, beautifully mysterious, and endlessly fascinating. Quantum physics doesn't just challenge our everyday intuition, it also raises profound philosophical questions. As we delve deeper, we find that the quantum realm doesn't just play by different rules, it also shakes the very foundations of our understanding of the universe. One such challenge is the interplay between quantum mechanics and relativity, Einstein's groundbreaking theory that gave us the concept of space-time. While quantum mechanics governs the subatomic world, relativity rules the macroscopic universe. Each theory is incredibly successful in its own realm, but when they converge, things get a bit tricky. This clash is most evident in black holes and the early universe, where the effects of both theories become significant. Here, physicists are trying to find a theory of quantum gravity that would unify these two seemingly incompatible theories. Quantum gravity is the holy grail of modern physics, a theory that could explain everything from the smallest particles to the largest galaxies. It's a quest for a grand, unified theory, the theory of everything. However, despite the best efforts of some of the brightest minds in the world, this elusive theory remains just out of reach. But the challenges of quantum physics don't stop there. Even the interpretation of quantum mechanics itself is a matter of ongoing debate. There are several competing interpretations, each attempting to explain the strange phenomena we observe. The Copenhagen interpretation, for instance, is one of the oldest and most widely taught. It suggests that quantum particles don't have definite properties until they're measured. It's the interpretation that gave us the famous Schrödinger's cat thought experiment. However, it also leaves us with the unsettling notion that the act of observation changes the state of the universe. In contrast, the many worlds interpretation takes a different approach. It posits that every possible outcome of a quantum event actually happens, but in separate parallel universes. So instead of the cat being dead or alive when we open the box, in one universe the cat is alive, and in a parallel universe the cat is dead. This interpretation, while mind-bending, eliminates the need for an observer to collapse the quantum state. There are many more interpretations besides these two, each with its own unique take on the quantum world. Some physicists even suggest that our reality is nothing more than a complex mathematical structure, while others argue that consciousness plays a crucial role in shaping the universe. Each of these interpretations offers a different lens through which we can view the quantum world. They challenge our understanding of reality, our place in the universe, and even the nature of existence itself. They push the boundaries of our knowledge and our imagination. These interpretations are still hotly debated among physicists, showing that our journey to understand the quantum world is far from over. As we continue to explore, to question, and to wonder, we are charting a course into the unknown, pushing the boundaries of our understanding and redefining the very nature of reality itself. In this fascinating world of quantum physics, the only thing that's certain is uncertainty. It's a world that's stranger than fiction, a world that's still full of mysteries waiting to be unraveled. As we delve deeper, we find that every answer brings with it a host of new questions, each more intriguing than the last. So let's keep questioning, keep exploring, and keep pushing the boundaries of our understanding. Because in the world of quantum physics, the journey is just as important as the destination. So where does all this leave us? What can we make of a world that's both wave and particle, certain and uncertain here and there? In our exploration, we've discovered a realm where particles can be in two places at once, where energy comes in discrete packages, and where observation changes the state of reality. We've seen how experiments like the double slit and Schrödinger's cat challenge our conventional understanding of the world. We've marveled at the eerie phenomenon of quantum entanglement and the mind-boggling potential of quantum teleportation. But beyond the scientific revelations, quantum physics opens up a wealth of philosophical questions. If particles can be in two places at once, what does that say about the nature of existence? Does reality exist independent of our observation, or does consciousness play a role in shaping it? And if everything is interconnected at a quantum level, what does that mean for our understanding of the universe and our place within it? These questions push the boundaries of science into the realm of philosophy, inviting us to reassess our assumptions about the world. While the answers remain elusive, the very act of questioning deepens our understanding and sparks our curiosity. Quantum physics isn't just about the behavior of subatomic particles. It's a lens through which we can explore the deepest mysteries of existence. The quantum realm is a world of infinite possibilities, where the rules of classical physics give way to a more complex, more fascinating reality. It's a reality that challenges our intuition, defies our expectations, and invites us to see the universe in a whole new light. As we continue to explore the quantum realm, we come face to face with the profound mystery and beauty of our universe. Quantum physics doesn't offer simple answers, but it does offer a journey of discovery, a journey that takes us beyond the familiar and into the unknown. Remember, in the world of quantum physics, things are never quite as they seem.